And yeah, the second speaker, I have an honor to introduce Oleksandr Katchur. And the topic is how JVM observability works, magic behind APM instrumentation libraries.
Yes, that's
Thank you, sir. Please go ahead.
Thank you.
Yeah.
Yeah, so hi, it's a bit late, so I don't know, let's try to make it a bit faster than it should be. Well, let's see how it goes. So yeah, that's the topic. My name is Oleksandr. I'm working in Wolt for 4+ years. Initially at platform team, then at a bit closer. Okay, sure. Then at performance and observability, and now at tech. So yeah, have a pretty much like lots of work to do. So yeah. As for like presentation today, you can expect well, a bit of a deep dive into APM observability libraries, using debugger, some of profiling, flame graphs, lots of pop culture references, and mediocre presentation skills. But first thing first, like Wolt, you might know us. We do like delivery, food delivery, all kind of deliveries, I guess nowadays. So yeah, our what?
A bit.
A bit.
Yeah, like this.
Okay.
Like this.
Okay,
so
okay.
people
like
look
this.
alive.
Okay, okay.
Yeah.
Yes. So this is Wolt in numbers, like lots of stuff nowadays, especially. So like 25 countries, 500 cities, lots of people, lots of work, quite nice reviews. So, Iceland is missing. Well, okay. Iceland is missing. So yeah, if anybody is interested, like we are hiring, even our team is hiring now. So yeah, please join, apply, join. So that's the state of JVM at Wolt. We have around 150 services using JVM in prod. It's really hard to calculate, but somewhere there. And around 210 like Python services. So like JVM is, well, kind of second platform, but in pair with our like the most popular one, Python. As for Go, we have some Go services. Only 20 or so of those. So why this talk? Well, everything started from the Slack message by Rami. Hi, Rami. He is awesome colleague of ours from Oulu. So he was pretty excited when we've added a Snowflake library to one of our microservices or services. And that's what we've seen from the get-go, like their Snowflake query. So this is span in distributed tracing view. So this is Datadog. We're using Datadog. But as we can see, like, well, almost all of APMs are, well, somewhat similar. At least on like Java library level. So yeah, he was like pretty excited and impressed because because that's pretty cool. Like we just added library and it's already there, and it like felt like a magic, as Agent Smith said. But maybe it wasn't Agent Smith though. But like nowadays, it's really hard find the truth. But this one, it was like Arthur Clarke, definitely. So the commit to support the Snowflake in Datadog is, well, pretty straightforward. So they added just 2 lines of code like to a connection instrumentation Java class and to prepare statement instrumentation class. And well, that's basically it. So feels like magic, right? So the goal of this talk is to reveal this advanced technology behind this magic that we can see. So about the Datadog. Well, Datadog is a observability platform. Observability nowadays consists only of like top 3 metrics, traces, and logs. But like for past 2 years, I guess there are talks about adding profiles there. As for now, I guess pull request to OpenTelemetry is open, but it's still like underway. And that's like official documentation how you instrument your application from Datadog side. Well, the most interesting line is the first one. Of course, the one with flight recorder options is pretty cool too, and probably we'll talk about it later, but like we want to focus on the first one, Java agent and pass to Datadog Java agent. So Java agents, and this like pass to Java agent. So basically Java agent is the way to, well, not to instrument, but like to attach to your application which is already running or you want to start. So this is basically two execution paths. I shamelessly stole this slide from Raphael Winterhalter, which is creator and maintainer of library ByteBuddy and library of Mockito. So yeah, you may know this guy. He's really, really knowledgeable, and if you're interested in the topic, I really recommend checking out his work. So his talks, his blog. So yeah, basically here we have like two kind of paths which you can use to like hook your Java agent into application. So pre-main and agent main. Those are basically entry points in pair to main entry point. This second one, attach thread and agent main, they are on the path to be deprecated. In Java 21, there is a JEP 451, okay, which states that it's like discouraged to use this execution path. But you have another one, launcher agent class, in the manifest added in Java 9. So you still have like some flexibility there. So pre-main, pre-main class is, well, the basically entry point which used in most agents that we will talk today about. And well, you are interested in this one if you are checking like a new Java agent or like APM library, as we are talking about APM libraries. Like first thing to check if you want to figure out how it works, find the pre-main method. So pre-main method, right? Well, this is example of Prometheus Java agent and how it works inside. So we found the pre-main, and what we see here, well, not that much, to be honest, like built-in collector and JMX collector, well, and obviously HTTP server. Is it like complicated? Well, not really, but what it does is just uses JMX collector and rules defined in Prometheus config to actually go through the JMX beans and expose this data through the HTTP server. So easy to comprehend, not that much. So is that it? Well, kinda no, because in Datadog, for example, well, yeah, those lines are not that handy, but yeah, in Datadog there are much more going on, much more. So we have here like some reflection, some like bootstrap agent trying to get class loader of it. So instead of just, well, pre-main another entry point, it's just a like huge set of infrastructure like inside JVM that needs to be kind of comprehend to be able to understand how things work. So that's the flame graph, and that's the like pre-main of Datadog. At this point, it's really tricky how to proceed, because like we can try to zoom in into the flame graph, or we can check the flame graph itself. But I have just one hand. Okay, let me maybe stop this, then reshare the whole desktop, and yes. So about application, this is basically, let me show you. This is basically pet clinic, right? So the the most obvious thing that you can think about. So, well, Spring Pet Clinic instrumented with Datadog agent. So, well, nothing too special. But what we can find here? What we can find here? So, connect. So at the beginning, we were checking the like 2 lines of code that been added to Datadog agent. Well, to be able to enable Snowflake support. So first one was added to connection info or something like that, and second one to prepared statement. So I just put into the search like connect, and most probably will find it here. Yes, here it is, get connection, and here we have it. Class loader, blah, 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 class loader, then instrumentation, transform, something similar. And then here it is, Datadog, trace, tooling, byte body, blah, 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 some familiar words. Then again, byte body, combining matchers, blah, blah, blah. Well, something going on here. So that's basically how things works. But as for details, let me start from here maybe. Yes, class loader. So as we've seen just now in the class loader, so like basically that's the, well, we may say like another big step after pre-main. So when we've like executed put our agent into a Java agent path, defined pre-main, then the class loader comes into place. Like it's really hard sometimes to comprehend how like class being loaded, because when you're like operating with agent, you're external to the like JVM running that you are trying to connect to. So like most of the time, it's better to use already some libraries like bytebody to handle this thing. But like instrumentation interface, which we will talk about now, has the really interesting feature, like ability to add transformation classes into the like class loader higher in hierarchy. So starting from version 1.6, like users are able to inject some transform classes right into Bootstrap class loader, which is a huge relief. But if some of your classes that you want to instrument loaded into like application class loader, it could be a bit tricky. So please use some already existing API for like bytebody. So instrumentation API. Instrumentation API, yeah, like about instrumentation API. Does somebody know who is this guy? No? Okay, so this is like John Cage, a really famous American composer. Mostly he's famous for his, composition called 133, like, or sorry, 433, like 4 minutes and 33 seconds of silence. But this work is from his early days, like 1938, 1940, when he started to like preparing piano, like putting some, as you can see, like bolts, clips, whatever, to change the sound of the piano. And well, that's exactly what instrumentation API does. It provides you some tooling to change your application, how your application behaves, like how piano behaves, application behaves, well, that stuff. So transformers. That's basically one of the most crucial methods that this instrumentation API provides you. So like in pre-main, there are 2 parameters, as you may seen, like agent arguments and instrumentation. And that's the instrumentation exemplar of the class, and you can like call add transformer class on it. So what's the transformer? transformer is the way or like instructions to redefine one class to another. Basically, it takes the bytecode of one class and with some, well, I don't know, some operation produces the bytecode of the class that you can change. And that's basically the whole chain of events. So transformers, what kind of tools or like things we can have as well defining those transformers. So ByteBuddy and ASM. Those are two projects that can provide you more, well, I don't know, user-friendly experience when you're defining your transformer, when you want to like transform one class into another one. So ByteBuddy really like user-friendly, and the API is so is so fluent, so you can't mistake your like instrumentation code that like transform your class with the actual class, because what it does basically, it's like you're defining not the class that will be how to put it, you're defining not the new class, but you're defining the template which will transform your class to kind of fit the, well, newly defined API, something like that. And ASM, that's basically a project that kind of make those byte transformations happening. So ByteBuddy using ASM. And ASM is low-level API and ByteBuddy high-level API. But we will talk about it a bit later. So, Jacoco. That's also like another project that uses, well, transformation, instrumentation, Java agents. So yeah, I don't know. Does somebody don't know like what Jacoco is? Okay. Oh, nice. Well, this is library in well, JVM ecosystem that produces the well, ability to show the code coverage. So if you want to check like how much of your code is covered by unit tests or like integration tests, so that's the tool to use. So yeah, basically they are also using Java agent. Here it is pre-main, and this is transformer, like what's actually being transformed. And like tricky part, or like most interesting part for us here, they, by the way, don't use the ByteBuddy, as far as I remember. So we don't support class retransformation. What the class retransformation is and why they don't support it. There are two ways to use those transformers: redefine classes and retransform. The thing is, with redefine classes, it's like old method supported prior to Java version 1.6, and if it's loaded by a class loader, then you can do, well, anything basically. So most of the time you're like aiming to use the retransform method or whatever approach. But the Jacoco using explicitly this redefine classes method because, well, they can, because they are like using this Java agent on class loading phase, so not that big of a problem, and they are not instrumenting like core Java libraries, so why to bother? That's one thing, and second one is they are like explicitly supporting version 1.5, so basically, yeah, backward compatibility. That's the manifest file of Datadog Java agent. So they're like supporting both redefine and retransform. Probably we will even cover this a bit later, but let's see. So yeah, back again into instrumentation, JDBC, and Datadog. So yes, so that's basically this flame graph, and what I've shown you previously is about like startup. What's happening on a startup without any load, without any requests produced. But what happens when actual like things start going on? So this is our JDBC prepared statement, because we were talking about, right, about prepared statement and connection and due connection, because that's the like two instrumented things that we have. And if we put in a search like Datadog, then basically that's the whole thing added after instrumentation. So if we can see what's happening here, like activate span, contribute scope manager, start span, yeah, set service name. So basically what's happening here is that on connection, span finish. Okay, so what the span is? Let me show you. Actually, yeah, we already talked about that, but again, yeah. So that one, like really tiny thing, that's the span. So basically this whole thing called trace, and this like tiny one called span. So basically at that point, Datadog just adding span into the trace object, and that's basically what's the whole like instrumentation in Datadog. Uh, well, yeah, that's the whole thing. We can check it in debugger. Like when I was thinking about this talk, I was like, it would be really cool if we can like go in debugger like through the whole execution process. Like, isn't it cool? Well, yes, but oh, sorry. But let's see. So that's one like some of things that we already talked about, but some maybe not. So here, what we are doing, or like what they are doing, they're like trying to find with reflection start method and execute it. Why so? Because it's preferred way to kind of load your agents into memory or like into JVM if you are working with really long running JVM processes. So let's say we are not like startups running Kubernetes and all that stuff, but like bloody enterprise, and our uptime is 100 hours, right? And at some point, we figure out that in Java agent, in Datadog Java agent, for example, there is a memory leak. What should we do? We can't stop things. Like it's already 100 hour, and maybe somebody will lose money on this downtime. So there is a way to actually change and reload Java agent that already running in production. So that's why it's implemented in such a well non-trivial or non-usual way. So everything like using reflection, everything using like class loaders. So yeah, that's like typical typical usage pattern, let's say. So yeah, so here what we are doing, we are like agent class get main agent class is Datadog bootstrap agent and method called start. So I put breakpoint there. Probably yes, here it is. But it's not that one. It's like about create agent class loader. So it is related to like what we've talked about previously about class loaders. It's yeah, it's not trivial stuff. So yeah, I would recommend you to check some Raphael talks about that, because yeah, that's another level of understanding. But here it is. So yeah, uh, that's the start agent code part, and like another thing that being like that executed is the agent installer and install byte body agent. And at that point, I realized, okay, so that's pretty cool, because we can proceed with our debug approach because of class data. So like a lot of files in Datadog agent, when it's already packaged into a jar, it's obfuscated. So, for example, I can't show you those 2 lines in the PR, like from this code, because it's obfuscated. But we have like source code, so because it's open source. So yeah, here it is, like Snowflake, that's the default connection instrumentation, that's the prepare statement instrumentation. So here it is. That's the like bootstrap, agent bootstrap that we've just seen with the start call. So with the start call on agent method, here it is. Here it is. Just a sec, start. So maybe I missed one step, but yeah, here it is start. Yes, I missed one step. So it was start, then start Datadog agent, and we are here. Then install bytebody agent from class bytebody agent. Right? No, not right. Well, install bytebody agent. Yeah, here it is. In any case, and what we have here, install bytebody agent, and yes, basically such configuration, like bytebody. Let me check if I have something else. Yes, combining transformer. Yes, here it is. So basically what's happening here? Here, those transformers actually created. So we have, remember about like redefinition and retransforming. So I assume this legacy transformer builder, that's like for Java 1.5, and this one for, okay. Yeah, so this one for a new one. So, well, basically here we are with the advice and actual transformer being defined. So that's the thing, like that's the kind of end goal, and what we have here as like as an actual like logic of the transformer. On enter depths blah 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 query info. So here it is. We are just getting from the prepare statement query info, and then at some point, yeah, we are like putting it into a span. Basically, that's the whole magic. That's the whole process. Yeah, maybe a bit hectic, but like it's 8 p.m. So Elastic APM. So here we have pretty much the same idea, same flow. So they have a pre-main, then then some bootstrapping, and then and then loading. Oh, okay, you even see my like cursor, and then loading loading agent like with delayed in it. But yeah, okay, here it is. And well, during the execution, exactly same pattern, like some code being injected at the end of the execution, end of the execution stack. So that's basically stack trace, or like lots of stack traces put into one flame graph, and that's basically it. So span try composite blah blah blah. So yeah, basically adding more spans into traces. So Mockito, as I mentioned, Rafael, author of ByteBuddy, he is nowadays a maintainer of Mockito library. So here we have same thing, but of course no pre-main, because the entry point for mocking is a bit different. It's like inside the test, so you don't have to like inject your agent into the running Java machine. So only transformation phase here. So yeah, as you can see, bytebody, redefine, blah blah blah. So like the main idea how it works is that when you're defining like expected execution result, you are creating advice for byte body to transform your like class that you are trying to, well, to call to instrument. So basically, yes, same process, and at the end, like get bytes, basically returning the bytes for a new class to be loaded. Challenges. So we are like 80% done or something. Challenges. So I've made kind of small demo. Sorry. Well, yeah. Well, let's leave it as it is. So basically, what we have here, we have, well, some kind of binary variables with defined values like true, true. Well, basic. This is like from, I don't remember, from well, from university logic course. So you have like predicates, like Socrates is a human and Plato is a human. So like for the is a horse, sorry, for the first one. So it's true, false. So well, I don't know. Maybe it's a bit too late for activities, but who think that it will be true? Okay, nobody. So false. Okay, nobody. So what are you expecting, guys and girls? Okay. Okay. Well, I assume it's too late for such type of activity. Okay. Well, let's see. Let's see then. False. Okay. So we have at least one guess. So yeah, it is true. Well, it is true for the first one. Yes, it is false. For the second one, it is false. So what's the guess for the third one? Well, that's the really tricky question because the right answer is out of memory error. Why? Why is it so? That's the point. Like that's the logic with instrumented agent, and what's the how it's implemented? Basically, this stuff it's not well. There is a reason why it's here. So it's Kotlin, and what I did, I like instrumented this particular method, which is to Boolean strict, and it's yeah. So that's the reason why it's like the second one wasn't true, and yeah, here we are like just throwing out of memory error. So the whole point of this, well, I don't know, kind of silly exercise, but yeah, is that when you have like Java agent inside your application, it's not quite your application because inside the agent, like there might be going on like whatever. And if you have something like latest, this is from like some of our repositories. Like as soon as repository is compromised, for example, like lately with Ubuntu translations, if you've like been following, so there were some really malicious translator inside the Ubuntu community, and he put like Ukrainian translation, well, not appropriate words, let's say. Yeah, if you're using like something like that with latest, so when your application next time runs, you don't actually know what's inside your application. So you can put, or like somebody malicious could put some code which will collect user data, for example, and send to, well, somewhere else or do whatever. I don't know, but like that's the concern. Memory leaks. Even we involved with like previous, it's combination of things usually. We've been faced this thing like late Friday, and obviously late Friday nobody would bother to like to patch anything. So yeah, it can get really, really, really tricky. So basically, this is everything from Datadog agent repository. So like too open, as you may see. Another one, not listed here, but like another one really great challenge is that GraalVM native images doesn't support fully this instrumentation interface. So if you are using Java agents like we are, Datadog or similar, and you want to build your GraalVM native image, well, no luck. It won't work. It barely works with reflection, with some hacks. Well, it's kind of streamlined, but not that great. But with agents, no luck. So yeah, and this is basically challenges caused by body and well, this advice kind of logic or I don't know, entity. So one thing I mentioned is that like programming model is really tricky because what you are writing in advice, for example, as I did here, here. So yeah, basically that's the advice to the method and how it's done. So by the way, check out the pretty Kotlin name. So that's the tricky part of the Kotlin library. So yeah, basically what I did is I defined that I want to instrument this particular method from this particular class, and like instrumentation advice would be stored here, like in string advice class, which is exactly here. So yeah, when you're like putting this code here, it won't be like adding as a like on the execution on the call graph, it won't be like calling this particular method. It would copy this code inside the class and retransform it into like new byte array. So if I'll put well breakpoint here, it won't trigger. So that's the thing. If you want to debug your Java agents, it's a tricky task to do. So that's the like first point. Programming model is really difficult to comprehend because here it is the code. Why like debug? Debugging doesn't work. Well, that's why. So no encapsulation because well fields are only static and we are like copying stuff. It's not like you can't store state there properly. So no lambdas because they're compiled to private methods, and private methods can't be accessed from well different place. So about trampoline, I've mentioned well at the middle of the talk. Stack map, yeah. So that's another thing. Basically, JIT compilator is really precise and sophisticated thing. So it's like there is inlining cache. There is like JIT recompilation on the code change. There is like a size limit to it. So like if some piece of code is already touched and compiled by JIT compilator and you are like redefining this code, it will like trigger JIT recompilation, and after that you may face some really bad performance issues because of this well inlining cache, size of the cache, and all that stuff. So yeah, not possible to trigger breakpoint. Testing. It's well, you have to use integration phase to test your Java agents because you have to have a jar file so that you can attach to it. So it's a bit tricky. Then agent ordering. So you have multiple agents, but they have to be ordered properly because like each premain, as we've seen like on well 7th slide or something, each premain like executes the next agent, and well ordering matters. Then JVM forks, like if you are using Gradle or Maven, they may fork the JVM, and you won't be able to attach from your agent to forked JVM. And well, for me personally, there were some issues with Jacoco and Mockito conflicts. Most probably it's because of byte body version, because like lots of libraries just like incorporate in byte body, and that's yeah, that could be a problem. So Wolts work with agents. So like our own Monosol is the contributor to Datadog, and if you are using in your work like Datadog with Kotlin services and coroutines, so yeah, that's the reason to say hi. So yeah, that's one thing, and another thing that I was working on. So that's why like I know a bit about how these things work. Is like we were using pretty well. We are still using a pretty popular load testing tool, and there are two versions of this tool, like open source and enterprise. So for open source version, there is no statsd protocol support, and pull requests that's been open, it was closed without like merging, with the reasoning that, well, unfortunately, that's our enterprise offering, and we won't kind of accept your pull request because it clashes with our like enterprise interests. So what we've done, we've created our own statsd implementation, put like statsd protocol into, well, parts of the framework that we can't, um, yeah, instrument with other way. And well, yeah, nowadays it's working and reporting data to Datadog. So takeaways. As we've seen, like most cases, APM libraries using same process like Java agents, instrumentation interface, byte body, uh, retransformation, creating bytecode and rejecting it with class loaders. It is very, very powerful tool, but with like great power comes great responsibility. So some links. If you're interested, in general, I recommend, like very, very recommend talks or like resources or anything from Raphael Winterhalter. So he's the man. Questions? Cool, cool.
Mind blown.
So
right? Am I right?
I expected something like that. So I don't know. Let's. Oh, okay, okay. Igor.
So my question is there a better alternative? Does, for example, I don't know, eBPF can provide any hooks into user code as well, or maybe not yet?
Well, answering to your first question, is there a better alternative? That's the better alternative. Like, yeah. During preparation, I've checked some papers, like white papers, and around year 2007, 2006, like this instrumentation part was released at Java 1.5, which is 2004. So like at 2007, there are only started to well to appear white papers which are showing that this is like really powerful tool to use, and all such of like all kind of things. As for eBPF, well, it's you have to think to figure out like is it possible, because initially, well, not initially, but in general, it's like it's not modifiable. So you are like just copying values from one place and putting them into well, basically into maps in like somewhere in your file system, so that you can check it from both kernel and user space. So you can probably build a new system, like new observability tool based on eBPF, and that's what lots of startups nowadays doing, but they are mostly focused on profiling. So there is such a Parka, like Polar Signals, then Pixie, lots of Pixie, for example, Pixie. So that's the thing. They did exactly that. They rebuilt observability tool based on eBPF. Yeah.
Thank you. You showed the Java agent had a lot of reflection. Wouldn't that affect performance? I guess like they did it because they wanted to hot reload the jar while the application is running. Couldn't they create another library or an agent for use cases such as ours?
Yeah, well, that's the thing. It's used only on instrumentation phase. So as soon as you instrumented stuff, you don't have to have like reflection on anything because it's already there. Like classes being transformed and put back into JVM. So it's on a startup. But that's a really good question because for applications which has like really strict requirements on a startup time, what they are doing, they are like using the second approach, not the pre-main, but agent main. What this agent main approach kind of helps you to do, to attach to already running JVM like at some point in future. So let's say you started everything, startup is fine, and then you are like instrumenting things. Well, I don't really like that approach, but it's there, it's possible. So yeah.
Guys, anybody else?
So, and like maybe there could be some another use cases for this Java agent application. I mean, let's say I need to I don't know, check some consistency or check something. Is it okay to like apply for instance, this Java agent, and if something wrong, like say some hash sums of some files are wrong or something, just nuke the app or like change the behavior totally. So
Yes, it is possible, and that's what Rafael mentions in one of his talks. So he been able to patch like old enterprise systems that been running for years, provide like a quick fix which was implemented through the Java agents, not to like redeploy all the stuff like test and well, you know. So yeah, basically you can alter, well, almost whatever you like, almost. So it's really powerful, and well, there are some quirks like if you want to instrument Java modules like Java internal libraries, there might be some problems, but as you've seen, like if you are using Kotlin or Scala, it's really straightforward. Oh no, actually, for Kotlin, it's not that straightforward because they have this inline something annotation which makes some of the methods compile time kind of, I don't know, like optimized, and in this case, well, you can't instrument them. Yes, because like initially this example was a bit different. This one, it was like true, and I was planning to instrument boolean equals. Okay, it's not that easy to write with the left hand, but boolean equals, yeah. So, or nah, let's maybe use different way around. So here equals. So that's the thing. So yeah, well, there is no even like implementation for this stuff. So yeah.
Guys, any other questions? Otherwise, Alex is still here, still alive. Thank you very much for your talk. It was very interesting. Thanks.